this total session through some whiteboard kind of thing. So it's not a PPT presentation. So we'll discuss problem by problem and try to understand that that how to deal with those problems. Basically, you will never expect that in those competitive exam that you will get a very direct kind of a problem that you are facing normally in your book. So what I expect that you can able to just by reading those reading the problem network given to you during this examination, you can handle it in a proper manner and in quick time. Just a moment. Hello. हाँ चलेगा. Okay, so now I'm going to share my screen. So let us start with something which is very popular among you. That is, whenever you are dealing with the network theory, you will learn about that. What are the network theorems, right? So these network theorems are normally based on these Kirchhoff's laws, either KCL or KVL you need to apply. But there are a few things that you need to remember while applying those particular theorem in the field of finding out that the solution whatever is asked for. So let us start with a problem, a pretty simple problem, right? So we may have a circuit something like this, suppose. Suppose this is 12 volt, this is 3 ohm, this is 1 ampere, this is 6 ohm. So this terminal AB.
Hello.
Yeah.
Sir, just to interrupt you, we are not able to see anything on the screen, sir.
It's not visible?
No, sir. It's actually it's black. Yes, now it's coming, sir.
Is it visible now?
No, sir.
Okay. Is it now visible?
Yes, sir. It's now visible.
Okay. So, so we have a circuit something like this, where there is a 12 volt voltage source, 1 ampere current source, 3 ohm and 6 ohm resistances, and the terminal A and B, across which we want to find out that what will be my Thevenin's equivalent voltage and Thevenin's equivalent resistance, as because it is a DC network. So I'm not calling it as an impedance, it is basically a resistance. So VTH and RTH. So how can I able to find it out? VTH. So VTH, as per the definition, we know that it's the open circuit voltage across the terminal, right? So we need to find out that what is the voltage at VA with respect to VB. And RTH, it's the internal impedance, or rather the internal resistance of the network with all sources set to 0. But when you are saying that all sources set to 0, it's only talking about the independent sources. And I believe that you all know that what is independent source and what is a dependent source. So independent source or dependent source, the difference is that the independent source, the very name suggests that it is independent of nature, it is not depending on anything. And dependent source means it is depending on some other variable in the network in which it is placed. Right. So it may be a voltage source, it may be a current source, and either of the sources can be dependent on a voltage or a current of other branch of the network. Right. So it may be a voltage dependent voltage source, a current dependent voltage source, and in the other way, that it may be a voltage dependent current source or a current dependent current source. So here both the sources which is being represented here, they are independent in nature. So if there is a dependent source, then they are normally represented either in this form as a voltage source or in this form as a current source, right? So just by seeing at the topology of the network, we can able to understand that there are only independent sources present in the network. So it's pretty easy to find out what is RTH looking back into the network and setting all sources set to 0. So how can I set this source set to 0? If it is a voltage source, I can just make it shorted, right? I can make it short here. And if it is a current source, I can open it. Okay. So now my circuit for RTH is simply something like a short circuit and then 3 ohm, and then there is an open circuit, and then again there is a 6 ohm, and this is the terminal, right? A and B. So if you see in this fashion, then what you can see across the terminal, that this 3 ohm and 6 ohm, they are basically in parallel to each other. So RTH will be nothing but 3 parallel 6. So that will be our answer for RTH. So half of the question is done. So if there are options, then if you see that your RTH is matching, then you need not to go for VTH finding out if it is a problem specific and there is no matching with the other options. But if you see that all the options are given having same RTH, then you need to go for finding out VTH. So you attack the problem in such a fashion that in a very short period of time you can able to reach the correct answer. Okay, so your half of the question is actually being solved in a very quick manner, because RTH finding out is nothing. Okay, but VTH, now how can you find out VTH? Okay, so what is there? There is a voltage source, there is one resistance, and then at this node there are two things present. One is this current source, other one is this resistance. Okay, and this is of course the reference node. So why I'm representing in terms of a node? Because in place of KVL, if you want to go for a finding out any solution in terms of KCL, then within a very few steps we can able to solve the problem. So it is always preferable, if it is possible, that go with KCL, right? So we go with KCL in this question also. So it is 12 volt, 1 ampere, 6 ohm. So this is terminal A. This is terminal A. So VTH is basically VA minus VB. VB is 0, we know, so I need to find out that what is VA. Okay. So how can I able to find out? So at this node, how many branches are connected? 1 branch, 2 branch, and branch 3. So there are 3 branches. Okay, so sum of the instantaneous value of the current at this node should be equal to 0, right? So that's what the KCL is saying. So I'll find out that what is VA minus 12 divided by 3 is the current which is flowing out of this node through this branch. VA minus 12 divided by 3. Then 1 ampere current is entering. 1 ampere current is entering. So it is minus 1 because it is leaving and it is entering. And then again leaving. So VA minus this reference voltage 0 divided by 6. So that is equal to 0. So you solve for this and you will get the answer of VA. So that is nothing but your VTH. Okay. So you see that you need to solve a single equation if you are going for finding out VA with KCL. So one single solution you will get this VTH. So you may have a confusion that how many loops are there. Even if there is a current source, then how to overcome this current source, because in KVL there is no scope of a current source to put it in the equation. And when you say that, I also know that if there is a voltage source, then I should not consider that voltage source also. But considering this voltage source is present between a reference and a node, so that means this node potential is known to us. So it is always preferable to go with the KCL if this kind of problem is there. So always try to see in that fashion. So it's a pretty simple problem. It is actually, it came in GATE in some of the year, maybe in 2014 or 15, I can't remember right now. So this kind of problem may come, but normally you will face a pretty interesting and a critical problem. Okay. So let us have a critical problem, maybe of this type. Again, I have a voltage source, a resistance, another resistance, and then I have a current source, but it is dependent in nature. Five kilo ohm. This is 10 volts. Sorry, 10 volt, and this is 10 to the power minus 4 Vx. So what is Vx? Vx is this open circuit voltage, right? So again, I need to find out here VTH and RTH, Thevenin's equivalent voltage and resistance. So open circuit voltage is referred as Vx here. So my VTH is nothing but Vx. So I need to solve for Vx. Right? So how can you solve it? Again, you see that if it is open circuited, then there is no current flowing through this 5 kilo ohm of resistance, right? So potential at this node is equal to the potential at this node. Then how many branches are connected at this node through which the currents are obviously passing? So this is one branch and this is another branch. Okay, these are the two branches, only two branches. So go with the solution. So Vx through this branch, if it is going away, then Vx minus 10 divided by 5k, right? Vx minus 10 divided by 5k is the current which is flowing away from the node, this node, and current which is entering must be equal to this which is leaving, because there are only two branches. So it is nothing but 10 to the power minus 4 Vx. So you can solve for Vx. What will be the value? Vx minus 10 is equal to 10 to the power minus 4 into 5k Vx. So that is, it is 0.5. And then Vx minus 10 is equal to 0.5 Vx. So 10 divided by 0.5. So that means 20 volt. So your VTH is known to you. Okay. Now you go with this option. That if you find out that only one option is having 20 volt as the value of VTH, then you need not to find out that what is RTH, because half of the question is solved, right? Because if there is a dependent source, then in the usual way of neglecting the sources while finding out RTH is not so easy. That's why I didn't start with finding out RTH here, right? So whenever there is a dependent source, it becomes pretty difficult to find out the equivalent impedance or equivalent resistance. Okay, because the reason is that the value of this voltage source or the current source, which is depending on the branch current or the voltage. Okay, so any branch current or any branch voltage, that determines the voltage and current of this particular source. So when we are neglecting the independent sources, then it's fine. But you are not neglecting any branch of the network. So that means that usual way of neglecting the sources of independent nature cannot able to get rid of these dependent sources. So in presence of a dependent sources, you cannot able to find out that series parallel combination of the resistance or the impedances for finding out the equivalent internal impedance. So that's why there are there are procedures of finding out equivalent impedance in presence of a dependent source. So what are those procedures? So that means if I have, I believe that you know this, but still a small recap. So if I have some network with dependent sources, okay, with dependent sources, and this is the terminal across which you need to find out the Thevenin's equivalent circuit or the Norton's equivalent circuit or anything. Okay, so I need to find out this. So how to find out the equivalent impedance? So RTH, suppose this is a DC network, so RTH or maybe R Norton. What is the way? The way, there are three procedures. Procedure number one, that at this terminal, you put one voltage source. You put one voltage source of known value. Okay, suppose this is 1 volt, right? And then, except the dependent sources, all the independent sources you make inactive. So current sources can be made inactive by open circuiting it. Voltage sources can be made inactive by short circuiting it. Okay. If there are some internal impedances or internal resistances present, then you need to replace with that internal resistance. That is of course. But in case of an ideal voltage source or current source, voltage source can be neglected or made inactive by short circuiting it, and current source can be made inactive by open circuiting it. Okay. So all the independent sources you made inactive, and dependent sources are still there. And then you are putting one known voltage source at the terminal across which you want to find out the equivalent impedance. So you find out that how much current is being injected by this voltage source to the network. Find out that current. Then your RTH is nothing but the known voltage divided by the current you have calculated. Right? So the terminal voltage and the terminal current, that will give you RTH. So if I say that I am expressing RTH in terms of a known voltage source, then in a similar manner, I can do this with a known current source also, right? So all the things are same here. That means you are keeping all the independent sources inactive. Dependent sources are still there. You are putting a known current source at the terminal, and then find out that what is the voltage across the terminal, or rather the voltage across this current source. If it is V, then your RTH is equal to V by known current source value. Okay, so I deliberately choose this 1 ampere and 1 volt for the simplicity of the computation. You can make it 100 or 10 or anything of your choice. Okay, but the value should be known to us. Or maybe you can put a value like V. So you will get the expression of this current in terms of V. Then the V will cancel out and you will get a particular value of RTH. Here also the same thing. You can make a choice of a current source which is equal to I, suppose. But you will get this terminal voltage in terms of I. Then I will cancel out and you will get a particular value of RTH. So there are two procedures, and also there is a third procedure. What is that? The thing is that you know VTH. VTH is what? It is nothing but the open circuit voltage. And you also know that I can find out the Norton's current, which is nothing but the short circuit current. Okay. So if you have open circuit voltage and short circuit current with you, then you can find out that my RTH is nothing but is equal to VOC by ISC. So whichever is favorable for that particular problem, you go with that. Okay. So let us try to solve RTH with the first method. Suppose I am applying this method. Okay. So how I will get it? So that means I am making this voltage source will be shorted, right? It is independent one. So I am making it short. Then there is a resistance. There is another resistance. There is a current source. And because of that current source, we are actually doing all these things. This is dependent current source. And then what I am doing, I am putting one known voltage source. Known voltage source, what is that value? The value is 1 volt. So what is the voltage across this terminal, which I initially call it as Vx. So the voltage across this terminal become 1 volt. So if it is 1 volt, then what is the value of this current source? 10 to the power minus 4 Vx was the value, isn't it? Much ampere. 10 to the power minus 4 Vx ampere was the value. So Vx is 1 volt. So it is simply 10 to the power minus 4 ampere. So this is 5k ohm. This is 5k ohm. Right? I need to find out that how much is the current being injected by this voltage source. What is the current injected by this voltage source? So that I need to find out. So how can I be able to find out this I? Again, you go with the KCL. Okay. So what is the potential here? The potential here is known to us. Huh? How much it is? It is 1 volt. It is 1 volt. With respect to the reference, it is 1 volt. Can I able to find out this potential V? Suppose this is V. So what will be the case? It is V by 5k, right? And then let us consider that this current is entering here, and this current is also entering here. So this is equal to 10 to the power minus 4 plus how much current is entering? This voltage is 1, this voltage is V divided by 5k, right? So 1 minus V divided by 5k. So I need to find out this 1 minus V divided by 5k is my I. Okay. So solve for V. You can solve for V. So we'll get the value. You can put the value of V here and you will get the current. And then your RTH will be equal to 1 divided by I. That will be RTH. Okay, so this is the way in presence of a dependent source, you can able to find out that what is the equivalent resistance or impedance if it becomes an AC network. Okay. Now let us take a very interesting problem. It's simple but interesting. So it is something like that. What I'm drawing? It's a schematic representation of a two-winding transformer. Okay, so what are the things is given? Here we have sine omega t. This is 1 ohm. This is V1. The current flowing through this is I1. This is V2. And this is terminal XY. So that means I have a voltage across this as VXY. Okay. So what I have, the knowledge that V2 is equal to VXY if it is open circuit. Open circuit condition. My V2 is equal to VXY. So it is asked that for ideal transformer, and I believe you all know that what is meant by an ideal transformer. So for ideal transformer, VTH and RTH you need to find out. What is VTH and RTH? Okay. So how can I be able to find out? Another information is given. This is 1:2 ratio is there. That means my N2 is equal to 2N1. Huh? So that means my V1 by V2 is equal to N1 by N2. That is equal to half. Also, I'll say that my I2 by I1 is equal to half. So this relation is known to us. Transformer. Now I need to find out VTH. VTH, for finding out VTH, I need to go for an open circuit condition at the output, right? So open circuit condition at the output means my I2 is equal to 0. So I2 equal to 0 means my I1 will be what? I1 also will be equal to 0. If I1 is equal to 0, then what will be the drop in this 1 ohm? The drop in this 1 ohm will be also equal to 0. So if there is no drop, then what will be the value of this V1? V1 will be equal to the source voltage. So that means I can say that this gives me that V1 is equal to my source voltage, which is sine omega t, right? So V1 is equal to sine omega t. So what is VTH? VTH is my VOC. Basically, it is VXY, huh? Open circuit voltage. So that is equal to, I know this is equal to V2. V2 is what? V2 is equal to 2V1. 2V1. So that means 2 sine omega t. So you see, it is an AC network, but with this ideal condition of the transformer, it is pretty easy to find out that what is the Thevenin's equivalent voltage across the secondary terminal of the transformer. Okay. So you find out the options actually. That what are the options? A, B, C, D options are given, and if you find out that one of the VTH is matching with this 2 sine omega t, then you need not to find out that what is RTH. Don't go with that, because 2 sine omega t is known to you, so you go with only 2 sine omega t. Okay. But still, how to find out this RTH? How to find out this RTH? So if I say that this is a source voltage, which obviously is an independent voltage, right? This is an independent voltage, so I can make it short circuit. So for RTH, I'm short circuiting it. This is 1 ohm. This is the primary winding. This is the secondary winding. And then what? Then what? Can I simply find out with the help of either this way that my RTH will be the combination of a series parallel combination of something like this? It's not. Because this V1 and V2, the voltage across the primary winding, voltage across the secondary winding, they are dependent. They are dependent. So this dependent voltage source force you to put either of these method 1 or method 2 or method 3 to apply for finding out your RTH or ZTH. So what I am doing, I am putting one voltage source here. So suppose this is of value, let us consider this is V, huh? This is V. So I need to find out that what is I. So my RTH will be equal to, or rather I should not say it is a RTH, put it from the very beginning as ZTH, right? Because it is AC. ZTH. So my ZTH will be equal to I by V. Okay. Now this is 1 ohm. This is the current I1 which is flowing in this. So what will be the relationship between I1 and I? How can I get it? So for that I need to find out that what is the relationship between I2 and I. I2 is flowing out of the circuit, isn't it? In a transformer, the current is flowing from the secondary winding to the load side terminal. But here I am going to find out that what is I. So that means the relationship between I2 and I is equal and opposite in sign. Equal in magnitude and opposite in sign. So if I know I2, then what is I1? The relation I will having is this one. I2 is minus I. So what is I1? I2 by I1 is equal to half. So that means I by I1 is equal to minus half. Okay. Now this is V1. This is V1. What is V2? There is no drop here. There is no drop here, right? So my V2 is equal to, because it is ideal, huh? There is no leakage resistance. There is no leakage resistance. Though this 1 ohm is given here, maybe it can be considered as the cable resistance. Okay, it is not the transformer leakage resistance, huh? Because it is ideal transformer. So no resistance is given here or impedance is given here. So I can say that the voltage, whatever I am putting here, must be equal to this terminal voltage of V. So that my V1 by V2 means V1 by V, that is equal to half. It is also known to us. So these two relationship is known to us. I by I1 is equal to minus half, V1 by V is equal to half. Then what we will do, I am having a loop here. Go for a KVL here. Okay. So what will be that? The voltage drop across this 1 ohm is I1 into 1, and then the current is flowing in this direction. This is also plus, this is minus. So plus V1, that must be equal to 0. So I1 plus V1 is equal to 0. So I am getting that V1 is equal to minus I1. So these are the findings I am having. So what I can write down about V by I then, because that is my motto, is to find out ZTH. ZTH is I by V, so I'll find out what is V by I, then I'll invert it. V by I. V by I can write down that it is V by I V1, V by V1 into V1 by I. So V by V1 is how much? It is 2. And V1 by I, V1 by I1 I know it is minus 1. And I1 is equal to minus 2I. So I can write down that this is equal to 2 multiplied by minus I1 by I. It is equal to 2 multiplied by 2. Sorry, it is V by I, voltage by current impedance. It is 4. So VTH is 2 sin omega t and RTH is 4 ohm. So as I told you that only if you have an ideal transformer, condition, then this problem can be solved in this fashion pretty easily. Otherwise it becomes difficult if it is not an ideal transformer. Then you need to go for that all the necessary condition for ideal transformer. Okay, let us take another interesting problem. So you all know, I believe, that what is maximum power transfer theorem, right? What is this calling? Maximum power transfer theorem. That if it is a DC, then the load resistance must be equal to the internal resistance for the maximum power to be transferred, and if it is AC, then the load impedance should be the complex conjugate of the internal impedance. Now, what is the way of finding out this condition? Finding out this condition is that you need to maximize the power. That means you are basically maximize the current flowing through that impedance, isn't it? And for that you go for the first derivative and equating it to 0 and get this condition. So if I have a circuit something like this, it is 10 volt, this is R, this is 6 ohm, and RL is given as 3 ohm. It is asked that find out R for PRL max. Okay. How may I have the maximum power across the load resistance for what value of R? Can anyone tell me? Anyone from you people can tell me that what may be the way of tackling this problem, finding out the value of R. You can give your answer through chat box. No answer is coming in your mind? I need to maximize the power through this resistance. So that means I need to maximize the current through this resistance. So when I am I'm going to get a maximum current. Maximum current through this will be there with a constant value of RL when my internal resistance is minimum. And when my internal resistance will be minimum, minimum means I have the option because it is varying now. It is varying. So it is varying means it has the minimum value of 0 and maximum value as infinity. It is varying from 0 to infinity. As because the range is not given, so you can consider that it can vary from 0 to infinite. So it may be short circuit to behave as if it is open circuit. Huh? So if it is short circuit, then it will short circuit this 6 ohm also. Then this circuit is left with only RL, and that will give you the maximum value of the current flowing through the RL. And when we have a maximum current, then you must have a maximum power at the RL. So this problem actually has nothing to do with the maximum power transfer theorem condition. Okay, it is from the general knowledge of your understanding of this problem that how we will get a maximum power if the current is maximum. Then how to make a current maximum? You will make this R equal to 0. That's the answer. So you need not to calculate anything. Okay. So it's a pretty interesting problem, what I feel. Okay, let's move to another important aspect of network theorem, that is a two-port network. So you will see that network theory problems are coming in the gate. Always there is a 10 to 15% of weightage, or maybe more than that. Year to year it will vary. And most of these questions are coming basically from these network theorems, then from the two-port network, and then from the transients. Actually, the initial condition. So this gives you of understanding by going through those previous year's questions that on which topic you're going to emphasize more. So this transient means it includes the Laplace as well. So both AC and DC transients. So you may be in the time domain and you may be in the frequency domain for solving the answer. Okay, and of course two-port network is there along with the network theorem. So a two-port network. So I know that two-port network means is what? It's a network, and then there are two terminal in this side, two terminal in the other side also, right? So if I have these two ports, so the port means the basic understanding of port means where the things can be exchanged, huh? Input and output can take place. Two ports, so two ports are there. So one is this port, other one is this port. So power and the voltage and current can be exchanged. Current can be exchanged through this. Okay. So what the way of the electrical network port is represented for? So I have some V1, I have some I1 here, and I have some V2, and I have some I2 here. Out of these four variables, so consider that two of the variables are independent in nature and two of the variables are dependent on those independent variables. Okay, depending on that, I am defining a Z parameter, I am defining Y parameter, I am defining ABCD parameter, I am defining H parameter, G parameter, and so on and so forth. Okay, so there are a few more. So basically, this Z, Y, ABCD, and H will concentrate on these four, and we could get the type of problems based on these basically parameters of two-port network. So one thing you just keep in mind that for Z parameter, I'm expressing V1 and V2 in terms of I1 and I2. Okay, in terms of I1 and I2, and just opposite thing happens for Y parameter. So where I1 and I2, they are expressed in terms of V1 and V2. Okay, so that means V1 and V2 are dependent variables, I1, I2 are independent variables. Here I1, I2 are dependent variables, V1, V2 are independent variables. So if somebody asks you that find out the Y parameter for a transformer, is it possible? Is it possible? It's not. Y parameter of transformer doesn't exist. Why so? Because V1 and V2, they are not independent, they're dependent on each other. Okay, just keep this in mind. Keep this in mind that Y parameter for transformer is not possible to find out. It doesn't exist, as because the condition for the Y parameter that V1 and V2 must be independent, I1 and I2 are dependent. But here V1 and V2 are dependent on each other, so you cannot have a Y parameter for this transformer. Okay. If I have suppose I have a network something like this. I have a network something like this. Okay. Let us consider that this is YA. Admittance is given, huh? Or if it is a resistance, you may say that it is nothing but that one by resistance or conductance. This is YB and this is YC. Okay, and this asks to find out the Y parameter of this network. So that means there is V1, this is I1, this is V2, this is I2. So you obviously can find out the usual way of finding out the Y parameter, starting from this basic equation of I1 equal to Y11 V1 plus Y12 V2, and then I2 is equal to Y21 V1 plus Y22 V2, and then what is Y11? Y11 is equal to I1 by V1 with V2 equal to 0. Y21 is equal to I2 by V1 with V2 equal to 0. Then Y12 is equal to I1 by V2 with V1 equal to 0, and Y22 is equal to I2 by V2 with V1 equal to 0. So in this fashion, but that means you will have to short circuit the input terminal and find out the values for Y12 and Y22, and you short circuit the open circuit short circuit the output terminal, and you will get the values of Y11 and Y21. So you can find out in this fashion for getting the answer, but you may not have that much time in your hand during this competitive exam. So just keep this in mind, that for finding out the Y parameter, which is in pi form, which is given in pi form, then it's pretty easy to find out the Y parameter. What it is, you can solve for it, but it will be something like this. So it is YA plus YB minus YA minus YA, YA plus YC. So you go with finding out the conductances, and then you add YA plus YB for the Y11, and then minus YA, which is common, minus YA again, which is common, and then YA plus YC for Y22. So this is your Y parameter. Okay. Similar kind of things actually is there for Z parameter also, if it is expressed in T form. If it is expressed in T form, so you will see, you will encounter a problem in your competitive exam in most of the times where the pi or T form of networks are given for two-port network problems. So it becomes pretty easy to go for finding out that y parameter for pi kind of a network and z parameter for a t kind of a network. So I can express in this fashion that if it is suppose it is z1, it is z3, and it is z2. Okay. So what is z parameter for this thing? So z parameter will be z1 plus z2, and that z2, this is z2, this is z1, z2 plus z3. Okay. So directly, just by seeing the network, that okay, fine, it is a pi form, it is in T form, you can directly find out that what is y and z. For example, one problem came in this way. This is 10 ohm, this is 10 ohm, this is 10 ohm, and it is asked that you find out y parameter. So you can go for finding out that you will keep this v1 equal to 0, go with the other parameters, you put v2 equal to 0, go for the other parameters, and in this fashion you can find out. But you can directly use this formula. You can directly use this formula. So what is ya? So this is ohm. The unit is ohm. Huh? So you need to go with that inversion of this. So it is 1 by 10, 1 by 10, 1 by 10. So it is 0.2 minus 0.1 minus 0.1, 0.2. That is the answer. That's the answer. Check for the answer, and if one of the option is like this, then that will be the correct answer. So you need not to calculate anything for finding out these the y parameter. Usual way of finding out the y parameter. Directly by having a pi network, you can put this formula. Okay. Another important information that you should keep in mind, that there are conditions, something like that. You have a reciprocal network. The condition is that y12 is equal to y21, or maybe z12 is equal to z21. So and the symmetrical network is y11 is equal to y22, or z11 is equal to z22. These are the conditions for reciprocal and symmetric network. Now, without going for the actual finding out this condition, you just see that if it is a resistive network, that means all resistances are present. If it is a resistive network, then it must be reciprocal. Okay. So if suppose you have to find out the z parameter, right, for a given network, you have to find out the z parameter, and you will see that the given network is resistive in nature. It's totally resistive in nature. Then you go for finding out the options, where you will find out that the option is having z12 is equal to z21. That will be the correct answer, because it is reciprocal in nature. So it must follow z12 is equal to z21, right? Or in the finding of y parameter also, find out that in which option to have this particular thing, that is y12 is equal to y21. Okay, knowing that the circuit is reciprocal, this must be satisfied, and the option which is having this particular thing, then that should be the correct answer. Then you need not to solve for it. You can directly find out the correct answer by seeing the option. Okay. And another thing is that if you don't see that this is reciprocal in nature, then, or maybe the option is something like that, it has all the options, or maybe 2 of the options or 3 of the options is obeying this z12 is equal to z21, or maybe y12 is equal to y21. So you cannot choose. Then you see the network. If it is symmetric in nature, means it should be mirror image. It should be mirror image. So whatever is there in this part, the other part will also be mirror image of this part. Okay. So if it is mirror image kind of a thing, the network is represented as the mirror image, then it must be symmetric in nature. So that means the option which is having this y1 is equal to y22, if it is for y parameter, or maybe z11 is equal to z22 if it is for a z parameter, then that should be the correct answer. So again, without finding out the actual solution, you can get the correct option. Okay. Let us have a problem for two-port network. So I must admit that 2-hour duration is not enough for giving you the hint at least for all the chapters of network analysis or network theory. But I am trying my level best to cover the parts, at least the main part, which you may encounter during the competitive exam. So this is a problem. It is asked to find out the Z parameter. Okay, asked to find out the Z parameter. I'm giving you the option. I'm giving you the option. The options are something like this: is -2, 1, -8, 3. Then -2, -8, -8, 3. 0, 1, 1, 0. Two, -1, -1, 3. Okay. Z parameter. What are the things we know about Z parameter? That if it is symmetric in nature, then Y11 must Z11 must be equal to Z22. Is it symmetric? It's not. If it is reciprocal in nature, then Z12 must be equal to Z21. Right? Is it reciprocal? It's not. Why so? Because there is a dependent source. So whenever there is a dependent source present in the network, it cannot be a reciprocal network. So this is a non-reciprocal network. So non-reciprocal network means I must have this condition: Z12 must not be equal to Z21. But you see, all the option except A, Z12 is equal to Z21. So my correct answer is A. So you need not to solve for it. You need not to solve for it. Even if you want to solve, then you can obviously solve for it. If you want to solve, you can solve for it. By putting that the things like either V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. Okay. Then you go for that, put I2 equal to 0, then you will get Z11 which is V1 by I1. We will get Z21 which is V2 by I1. And then you put I1 equal to 0. I2 and I1 equal to 0 means what? You need to keep the input port open circuited or the output port open circuited. Then you will get for I1 equal to 0, you will get Z12 and Z22. Z12 is V1 by I2 and Z22 is V2 by I2. So I'm not solving it. I didn't have to solve it actually, because I know this condition, so my answer will be this. Okay, fine. Let us have another problem from two-port network. I'm putting a complicated circuit, but if you want to see it in a manner, then it is having some kind of a symmetry. The values is 3 ohm, 3 ohm, 3 ohm. This is 2 ohm, 2 ohm, 2 ohm. So how can I able to simplify this circuit? How can I able to simplify this circuit? You see that this node is connected here, and it is also connected here. This node is connected here, this is also connected here, right? So that means this 3 and this 2, these 3 and these two resistances, they are in parallel to each other, isn't it? Because across this node I have 3 ohm, across this node I have also another resistance which is 2 ohm. So that means this 3 and 2 are in parallel. Similarly, you see this resistance is across this node and this node, right? This 2 ohm, this is also across this node and this node. So that means this 3 and 2 are in parallel. Similarly, this 3 and 2 also are in parallel. So how can I present it? Can I represent it in this fashion? So it's a parallel combination of 3 and 2 in each of the branches. So it's 5 by 6, it is 5 by 6, it is 5 by 6. Hmm? 5 by 6 is what? 5 by 6 is the, because it is pi, huh? It is pi. So I'm writing down directly the y value, huh? Admittance value. So what I can write down? That my I1 is equal to y11. Y11 means ya plus yb. So 10 by 6 v1 minus ya 5 by 6 v2. I2 is equal to minus ya, huh? v1 plus ya plus yc 10 by 6 v2. The question is that you find out H22. So what I am doing with this? H22 is what? H22 is basically I2 by V2 with I1 equal to 0. Okay. So I2 by V2 with I1 equal to 0. So you can put I1 equal to 0 here in this equation. You can put I1 equal to 0. Then you will get a relationship between V1 and V2. You can put the relationship here in this V2, in this V1 in terms of V2. Then you will get a relationship between I2 and V2. So from here you will get the value of H22. So answer can be obtained. Right? The thing is that I am not started with H parameter directly, because I have this option of pi. I can able to see this pi here in the equation or in the network. So I just form my y parameter equation, and from this y parameter equation, by means I'm able to find out that what it is asked for H22, I2 by V2 with I1 equal to 0. Okay. Fine. Let us move to another important topic on the network theory, that is initial condition of the network transients. So this is 3 volt. A switch S1 is there, which is closed at T equal to 0. This is 1 ohm. This is 1 Henry. This is S2, which is closed for a long time. So at the very beginning it was closed. This is 3 volt. It is asked to find out d dt of IL 0 plus. IL, the current flowing through the inductance. The rate of change of the current flowing through the inductance, that I need to find out. Okay. Now what I know, the relationship between the voltage and the current through this inductance. So I know that my VL of t, it is equal to L d dt of IL of t. So if I put in place of t, I'll put that 0 plus. Then VL of 0 plus is equal to L d dt of IL of 0 plus, isn't it? So what is d dt of IL of 0 plus? That is equal to L is what? 1 Henry. VL of 0 plus 1 by L, VL of 0 plus. So L is equal to 1 Henry, so it's simply VL of 0 plus. So you need to find out basically VL of 0 plus. Okay. So let's see in two parts. 2 parts means one, that t is less than 0. T is less than 0. When t is less than 0, this switch is open. If this switch is open means this part is out of the circuit. And it is said that this switch is closed for a long time. If it is closed for a long time, then at t tends to infinity, in the steady state condition, how this inductance will behave? It will behave as if it is short circuited. Then I left with the circuit for t less than 0 is something like this. This is 3 volt. This is 2 ohm. And it is forcing a current, which is nothing but the current which is the initial current of this inductance when this switch is closed. At this event, at t equal to 0, this becomes the initial current. So the inductance was not relaxed actually. It has its initial current inside it. Okay. So what is this I0? I0 is equal to 3 by 2. Okay. Now we'll go with that. What should be the case for t greater than equal to 0 condition? For t greater than equal to 0. For t greater than equal to 0, I have the resistance something like this. What I should put here? Just at the moment of 0 plus, I need to find it out. So just at the moment of 0 plus, it is behaving as if it is a current source of value I0. So this is 3 volt, 2 ohm, 1 ohm, 3 volt. So the voltage at this node is the voltage across the inductance, and that will be VL0 because I am putting I0 here. Okay. I0 is how much? 1.5 ampere. Huh? So can I able to solve for this voltage? VL. Go for node analysis. KCL. VL minus 3 by 1 plus VL minus 3 by 2 plus 1.5, that is equal to 0. So that means V3VL is equal to 6. Huh? Therefore VL0 plus, that is equal to 2 volt. Therefore, d dt of IL0 plus is equal to 2. Unit cannot be equal to volt. It is equating with the magnitude, not with the sign. It is d dt, current with respect to the time. So it is ampere per second. Okay. So you see how we have handled it. Though it is asked to find out something which is in derivative form, but we didn't go for this directly finding out the derivative form. We equated it by the known value or the known expression between the current and the voltage of across the inductance. And we'll find out this voltage, which is pretty easy to find it out, and we'll getting the actual answer. Okay. Let us have this equation, this network. Millihenry. This is 10 ohm. This is 10 ohm. This switch is closed at t equal to 0. The current flowing through this is I of t. This is also 10 ohm. This is 15 ampere. It is asked to find out I of t. That means the expression. You want to find out the current I of t. So we can handle it with the help of Laplace. We can handle it with the help of remaining in the time domain. And for that, if you want to handle it remaining in the time domain, then you have a beautiful formula in your mind. So keep this formula in your mind. So I of t is equal to I infinity plus I of 0 plus minus I infinity into e to the power minus t by tau for t greater than or equal to 0. Only thing is that if tau is finite value and non-zero, if finite and non-zero, then only you can solve for IT with the help of this equation. Otherwise, not. Okay. So let me see that how can I handle this equation. So I have to go with 3 conditions, or rather 2 conditions. One is t less than 0. So for t less than 0, this switch was opened. This switch was opened, and this will behave as if it is short circuited, right? So I have left with 15 ampere, which is flowing through these 2 parts of the network, having a resistance of 10 ohm and having resistance of 10 ohm again in the other branch. So that means I have a 15 ampere which is flowing through this 10 ohm and which is flowing through this 10 ohm also. So my IL0, this current flowing through this, it is 15 is divided in 2 parts, so it is 7.5 ampere. What will for t greater than or equal to 0? T greater than or equal to 0. The circuit will be something like this. And I have a current source here, right? This is 15 ampere. This is 10. This is 10. This is 10. This is 7.5 ampere. Okay. So how can I handle it? Tell me. So the current through this I'm looking for, huh? Current through this I'm looking for. So I need to find out that what is my I0 plus. What is my I0 plus? That I'm looking for, because I'm going to apply this equation. And after that I will also apply this t tends to infinity case. So I0 plus, can we find out, if I will to find out that what is my V0 plus? Then V0 plus divided by 10 should be equal to I0 plus. Then what is V0 plus? So voltage at this node. Voltage at this node. How can I able to find out? The current which is flowing through this is 7.5. Current which is coming here is how much? This 15 amps is actually now flowing. 15 amps is flowing through these three parts. 7.5 is flowing here. So rest of the current is flowing through this. 15 amp is now divided. 7.5 is flowing here. Rest of 7.5 is flowing through this 10 ohm and 10 ohm. Are you getting this or not? So my V0 plus is equal to 3.75 volt. So I0 plus is equal to 3.75 divided by 10 ampere, which is equal to 0.375 ampere. Right. What is RTH? Looking back into the terminal with respect to this inductance, this is open circuited. So I have 10 ohm, 10 ohm, 10 ohm here. So RTH will be 10 plus 10 parallel 10. So that means 15 ohm. And what is tau? So this inductance is actually seeing the resistance in the rest of the circuit, that is RTH, with respect to the inductance. So tau will be L by RTH. So that means 15 10 to the power minus 3 divided by 15. So 1 millisecond. So it is finite. It is finite. So I can use this. So what will be infinite? T tends to infinite. How the circuit should look like? The circuit will be again of this form. This is sorted. This is 15, 10, 10 and 10. It will be divided. So the current flowing through this will be 1/3 of 15. So I infinite is equal to 5 ampere. So I have all the values now. IT I can able to express. It is 5 plus 0.375 minus 10 by 10 na? 0.5 to 0.5. Okay, it's not 15. Sorry. It is 1.5. It is 1.5. 1.5. It is 1.5. So it is not 7.5. It is 0.75. So even if it is 15, then it will. It will not be like this. So it is 0.5. 0.5. It is 0.5. Then e to the power of minus t by tau. Tau is 1 millisecond. So your answer will be 0.5 minus 0.125 e to the power minus 1000 t, that much ampere. Okay, that will be the answer. Now, as I told you that the tau should be finite and non-zero, then only I can apply this. So, what will be the case for this particular condition? So, I have a circuit something like this. This is a capacitance. This is a switch. Again, there is a capacitance, and this is the circuit. This is C1. This is C2. The current which is flowing through this is I of t. The switch is closed at t equal to 0. It is said that C1 and C2, they are ideal capacitor, and Vc1 of 0 minus is equal to 12 volt. Vc2 of 0 minus is equal to 0 volt. So what will be I of t? What is the nature? Basically, the nature of I of t, it is asked. So you see that find out RTH. You don't have RTH, and you have C equivalent, C1 C2 divided by C1 plus C2. So your tau is what? Tau is 0. So you cannot apply that I of t is equal to that equation. That cannot be applied. The previous equation. This equation cannot be applied for this case. So what do you need to do? Then you go for a Laplace. If you can't apply this equation in time domain, remaining in the time domain, then you go for a Laplace. So for Laplace, how can I able to convert it? So C1 is having some initial voltage, so it will be having some voltage source, and this is having 0 voltage, so it don't have a voltage source. It will be 1 by C1s, 1 by C1s. This is 1 by C2s, and what will be this? This is Vc0 minus by S, isn't it? So that means it is 12 by S. And the current which is flowing is I of S. So you can find out I of S, isn't it? I of S is equal to what? It is this voltage divided by this impedance. So that means 12 by S divided by 1 by C1S plus 1 by C2S. So that means 12 C1 C2 divided by C1 plus C2. It is independent of S. Can you able to see that? It is independent of S. So what is I of t? L inverse of I of S. So if it is a constant, I of S is a constant, then what is the nature? Laplace inverse will be of nature of a impulse. So it is impulse in nature. Right? I of t will be impulse in nature. Let us have another. This is 10 volt. This is 1 farad. This is 5 ohm, 5 ohm, 5 ohm, 5 ohm, 5 ohm. Vc0 minus equal to 0. It is asked to find out that energy in joules. Transferred from the DC source until steady state is reached. That you need to find out. What is the energy in joules transferred from the DC source until steady state is reached? Huh? Now, this is a balanced bridge, isn't it? It's a balanced bridge. If it is balanced bridge, then how much is the current flowing through this branch? This is 5 ohm, this 5 ohm, this 5 ohm, this 5 ohm. So this branch will carry zero current. Huh? Or maybe I can say that the potential at this point and the potential at this point are same, or the potential across this is zero. Okay. So in either of the cases, your equivalent resistance is 5 ohm. So that's the way this is being solved in so easy form. So equivalent resistance, whatever may be your logic, it's a balanced bridge, the current is flowing through is zero, or the voltage is across is zero. That means you can omit it. Huh? You can omit it. Then equivalent resistance will be equal to 5 ohm. So I have a circuit something like this now. This is 1 farad, this is 5 ohm, and this is 10 volt. So what I have again, I of t is equal to I infinity plus I of 0 plus minus I infinity into e to the power minus t by tau. Right? Tau is equal to what? Is equal to 5, huh? 5 second. Tau is equal to 5 second. What is I0 plus? I0 plus, initially it is behaving as if it is short circuited, and after that it will behave as if it is open circuited. Huh? So I0 plus is 10 divided by 5, 2 ampere. And I infinity, as I told you, that with time it will behave as if it is open circuited. So current flowing through this will be 0. If it is open, then it becomes 0. Current will be 0. So I infinity is 0. So I can put the values here. So I of t is equal to, knowing this is 0, this is 2 e to the power minus t by 5 ampere. Then what will be the energy? So I need to find out the power. Power is the voltage multiplied by the current. So it is 20 to the power minus t by 5. So energy is what? Energy is steady state, huh? Up to steady state. So infinite, t tends to infinite, 0 to infinite. Integration of the power, that will give you the energy. So that means it is 20 minus 5, huh? To the power minus t by 5, 0 to infinity. That means it is 100 joule. So that will be the answer. Okay, that will be the answer. So we have basically seen so many problems coming to the completing of my 2 hours of duration, I believe. It's still 15-20 minutes are remaining. So let's having few more interesting problems. Suppose I have a circuit something like this. This is 100 volt. This is 80 volt. and this is 15 volt. The current which is sending is 10 ampere. This is 8 ampere. Then it is asked that what is the total power absorbed? Total power absorbed. It is asked. So P absorbed. P absorbed equal to. So what is the current flowing through this? So you apply KCL here, na? You will get it. 10 ampere is entering, 8 ampere is leaving. Then there must be some 2 ampere which is also leaving. Now you see, if a current is flowing out from the positive terminal of the battery, then it is generating. And if it is flowing out from the negative terminal of the battery, then it is absorbing. Okay. So in that case, this 100 is absorbing, but this 8 ampere and 2 ampere, it is generating. So this sum will give you the net power absorbed, right? So this is 1000 minus this is 640 minus 30. So that means total power absorbed is 330 watt. Right. So these are all the problems what I have discussed till now. They came in GATE exam in different times. Another beautiful problem let us have with this circuit. This is 1 volt. This is 1 volt. This is 2 ampere. This is 1 ohm. This is 1 ohm. This is 1 ohm. It is asked to find out the power delivered by 2 ampere source. Power delivered by 2 ampere source. Okay. So how can I find it out? So if I get the voltage at this node, then voltage multiplied by this current will give you the power delivered by this 2 ampere source. So I need to find out the voltage here, V, right? So that means go with the KCL. But I don't have this voltage to us. It is unknown to us, V dash. Okay. So how can I get this voltage? So you need two equations for these two nodes. So what are those? So this node is having 3 branches connected. So V minus 1 divided by 1 plus V minus V dash divided by 1, that is equal to 2. And with V dash, what I have? See, you go with the outer loop. You go with the outer loop KVL. What you will get? 1 volt, then minus 1 volt. So net voltage at the outer loop is 0. So the potential at this point, no current will be flowing through this 1 ohm. No current is flowing through means with respect to the reference, this voltage is 0. There will be no current flowing through this. So that means V dash is equal to 0. This is the interesting thing that you can able to find it out. Okay. V dash is equal to 0. So with V dash is equal to 0, you have V plus V is equal to 2. You can find out the value of V, and it should be multiplied with the current 2, and you will get the power. Okay. What is the value of V? It is V minus 1 plus V is equal to 2. So 2V is equal to 3. So V is equal to 3 by 2. So 3 by 2 multiplied by 2. 3 watt. Right? That's the answer. So small problems. But somehow there is a small trick. You need to catch that trick. So it will only come out practice from different books. There is all standard books are available. Go with practice all those books, and then just by seeing the network, you can able to understand that. Okay, fine. Use this trick, and you will get the answer in quick time. Okay. Another problem. You see, just by seeing this network, it will give you a lot of discourage to solve this, but it's pretty simple. So it is something like this: resistance, then a capacitance, inductance, again another resistance. It is having AC source connected. It is having a DC source connected. So all the things what you can imagine, all these there in this network. The value of this is 5 pi sine of 5000 t, something like this. And this is 5 volt. The value of this is 1 kilo ohm. This is 1 microfarad. This is 1 millihenry. This is 2 kilo ohm. Right. Now it is asked that I have these two nodes, A and B. This is positive. This is negative. This is A and this is B. So VAB average value. VAB average value is equal to what? At steady state. So this particular network will not encourage you to go for solving of it. But you see that you know the basic of understanding of a network. When there are more than one energy source is present, then go with the superposition. Okay, go with the superposition. So you have two voltage sources present. Maybe one is AC, another one is DC. Doesn't matter. Superposition is applicable to all linear network. So there are all linear elements are present. So I can apply superposition. So let us consider that my AC source is 0. AC source is 0. That means it is shorted. If it is shorted, then this 5 ohm is only present. So with 5 ohm present in the network, the average value at steady state across the capacitor will act as if it is open circuited, isn't it? So if it is open circuited means the voltage will appear across this open circuit. All the voltage of this DC source will appear across this open circuit because it is open circuit, so no current will be flowing through this. So there will be no drop. There will be no drop. It is short circuit. No drop in these resistances. So all the voltage will appear across this VAB. So my VAB average at steady state, it is dash maybe, it is equal to 5 volt. And then DC source equal to 0. When DC source equal to 0, then there is a sinusoidal energy source, voltage energy source is there. So what will be the average value across the capacitor? As because it is sinusoidal, the voltage across this will be, I know that sinusoidal voltage average value is equal to 0. So my DC source equal to 0, my VAB double dash average value, that will be equal to 0. So your VAB is what? It is VAB dash plus VAB double dash, that is equal to 5 volt. So you actually didn't calculate anything and you will get the answer. But initially it looks like that it's so complicated. So I'm just giving you time that if you have any question in your mind, then you can discuss. Otherwise, this is never ending. I can go on solving of many such problems one after another. If you have any particular question, then you can ask. Another thing
Okay.
before starting this question answer, let me give you a hint of another thing. There is something like it can come in terms of that I have um, coupled inductance in the network. Huh? So this may also come in sometimes coupled inductors. So suppose I have a voltage source, then maybe one inductance here, another inductance here, maybe one resistance, another voltage source, something like that. Huh? I'm just taking it. A coupled inductor means I must have some dot representation. Okay, I have some dot representation. So if I place it in this fashion, then how can I solve for the currents? How can I solve for the currents? Let it be in the frequency domain, but you need to create the circuit first with these coupled inductor cases, because you know that when there is a coupled inductor, then there must be the voltage induced voltage will be created in the branch because of the current in the other inductance, isn't it? And what about this? This is something that one dot is there. So one dot means actually it will tell you that if I have a voltage potential of particular sign, then the other also follow the same sign. So that's what the beauty of this coupled inductor is there. So if I come up with this, then how can I able to solve with this particular thing? So let me have it. Suppose this is L1, this is L2, and I have a couple mutual inductance which is M. Maybe this is R1, this is E1, this is E2, and something like that. Okay. So I need to find out, or E1, let it be small E1, small E2. This is I1 of t, this is I2 of t, that I want to find out. This M is given. So how can I solve for it? How can I solve for it? So I know that this current, the current which is flowing through this inductance, it will create one induced voltage in this branch, and the current which will create an induced voltage here. So this will be, these two voltage sources will be the dependent voltage source, which is nothing but a current controlled voltage source, right? So the current in one branch will control this voltage, right? So as because it is a dependent voltage source, so what I will do, I will represent in terms of this specification of. Now, one big question is that how will choose this potential, right? This is L1, L2. I will choose this, right? So current flowing through this is I1, huh? Current flowing through this is I2, okay? This is I1. What will be the value of the voltage source? Value of the voltage source will be M ddt of the current flowing through this. What is the current flowing through this? It is I1, isn't it? So I1. And this will be M ddt of current flowing through this is how much? This is the resultant current, because it's a common between these two loop. This is a common inductance present. So I1 minus I2, or I can say that I2 minus I1. Whatever you feel like. Let that as because I'm considering the current flowing through this branch maybe for this particular loop. So let it be I2 minus I1 in this fashion. I2 minus potential. That will create a lot of problems. So keep this in mind in that fashion. So you just imagine that suppose current entering this dot means it is positive, current leaving this dot means it is negative, or vice versa, whatever. Okay. So what will be the case that if I say that for this particular case that current is entering, right? Current is entering, so I am considering this as a positive. So if this is positive, then this is negative. So if this node, this particular dot is having a positive, then this particular dot will also be positive. Okay, and this will be negative, right? So if you have this is positive and this is negative, then you take this potential and you put it here. Okay, mechanically you just remember in this fashion. So I have decided this is positive as because current is entering this dot. So this dot will follow this particular polarity. So this is positive means this becomes positive. Okay, this becomes positive. If this becomes positive, then this is negative. So you take this positive negative and you put it here. Right? Now we go with this. That the resultant current I have written here as I2 minus I1. I2 minus I1 means I2 is flowing in the upward, I1 is flowing in the downward. So I2 minus I1, the resultant current is flowing upward. That means it is leaving dot. If it is leaving dot, then I will put this dot as negative. If this dot is negative means this is also negative. This is negative. This is negative means this is positive. Then what I will do? I will take this polarity. I will put it here. So this will be the polarity. Now you can easily find out that that what will be the equation after converting in the S domain. This will be SL1, this will be SL2, this will be M into S into I2S minus I1S, this will be M into S into I1S, this will be R1, this is E1 of S, this will be E2 of S. So you can easily form the KVL equation and can solve for I1S and I2S. Okay. So just keep this in mind that don't confuse with this dot convention and the polarity convention. Just take consider this very mechanically and remember for the polarity of the networks in case of the coupled inductor case. Okay. Yeah. Any question from your end?
Hello.
Yes.
Sir, am I audible?
Yes, you are audible.
Okay, so students, now the discussion forum is open. Our honorable expert is ready with the discussion forum. So if you have any questions related to today's topic, please ask your questions.
You can directly ask or you can write down in the chat box also, no issue. Whatever.
Yeah, that can be write it on the chat box also. Okay. So I think if there is any question, then we can always get in touch with sir. So
yes, of course.
at the out. Yes,
So
sir.
I have my
So
mail
at the
ID with Shah sir, so you can take my mail ID. If any confusion, you can directly contact with me through mail.
yes, sir. So at the outset, on behalf of the Department of Electrical Engineering, Tulsiramji Gaikwad Patil College of Engineering and Technology, sincere gratitude to you, sir, for sparing your valuable time to extend your support to take a lecture on the circuit analysis and give a bank of questions to our student. And definitely, as in your lecture, you have said 2 hours is not enough. So that I also feel that 2 hours is not enough. So we hope that we shall be get in touch with you again in the coming days. And today you have given our students details about the network theorems, support networks, and the mutual inductance topics, and many such topics, and also given the tricks to our student by which they can solve the questions with a less time. So
Right.
I think that that was the best part of the lecture today. So I hope all our students have got a brief overview of how to deal with the questions related to the circuit analysis in the gate examination, and I hope they will get a very good idea from this session that how to solve the questions related to circuit analysis. So thank you once again, sir, from the department, and
Thank you.
we would like to associate with you in the coming future also, sir.
Yes, of course, no issue. And thank you very much for giving this opportunity to give the lecture on network theory. It's one of the basic subject. It's one of the basic subject, and it's very close to my heart actually, this subject. And I feel that electrical engineer must have the knowledge about this, not because that it is coming in the in the competitive exam, but for dealing with the other electrical subject. This creates the base. This network theory creates the base. So thank you very much for inviting me for giving this lecture. Thank you.
Yes, yes. Thank you so much, sir. So students, please be connected. I'll share the attendance link right now. So
So sir, I'm leaving now.
yes, 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 sir. Yes, sir.
Okay, thank you.
Uh, so students, please be connected. I'll share the attendance link. Sir, you can leave now, sir. Thank you so much, sir. So just give me a moment. I'll share the attendance link. So I have posted the attendance link. So you can give your attendance. And as we have already said that we have started with the complete week with the guest lectures, expert rather expert talking in terms of the guest lecture. It would be called as an expert lecture, wherein we have arranged the lectures of several experts from the NITs, Government College of Engineering. Today we have completed with the first topic related to the circuit analysis. Tomorrow we have a lecture on the control system. So the control system part is also very important when we talk about the gate exam or any of the competitive exam related to the electrical engineering. So tomorrow we will be having the lecture on the control systems, but the timing will be somewhat different. So we will convey the timing. So for what it is asking the question, Dhanashri, permission for which it's asking the permission. I don't think it's not asking any permission for attendance. Okay. Okay. Is it asking permission? Okay. Okay. Just give me a moment. Just give me a moment.